Hi everyone, this is your struggling CS student here. Today let's solve another LeetCode problem of the day. Let's take a look at today's problem. 3461. Check if digits are equal in string after operations 1, which suggests there's a harder version. But since this is only 1200 rated, it shouldn't take too long, I hope. And maybe we will take a look at the second variant of the problem. Maybe it's tomorrow's problem, who knows. So you're given a string S consisting of digits, okay? Perform the following operations repeatedly until the string has exactly 2 digits. For each pair of consecutive digits in S, okay, starting from the first digit, calculate a new digit as the sum of the 2 digits modulo 10. Replace S with the sequence of the newly calculated digits, maintaining the order in which they are computed. Return true if the final 2 digits in S are the same, or false otherwise. Okay. Yep. At the final two digits. Final two digits. Okay, so this becomes 2, right? So we get 202. A. First operation. For each pair of consecutive. Oh, I see. So you have to keep doing it. It's not like 3 plus 9 is equals to 2, and then the 202 has some sort of cascading effect. Nope, you just transform the string into, so from 3, you transform the string from like length of n to n minus 1 to n minus 2 all the way until the length of 2, right? So in this case, you will perform 2 operations. Get 292, then you do it again, there'll be 1 and 1. Ah, okay. Yeah, I think in this case, we can just do a simple simulation. Let me check if there's a similar question to this. Is this the next question? Wait, 3463. Okay. Oh, what the hell? Hell nah, man. Ah, okay. I see. So here the s dot length is only 100, but here s dot length is up to 10 to the power of 5. And the reason I say hell no is because um, I watched Programming Live with Larry, and if he took 1 hour and 45 minutes, there's no chance, no way in hell I'll be able to solve this question. This is also rated to 2200, so okay, as for this problem, we can just brute force it and simulate the operations, and then we'll be able to get the answer. So let's just do that. Um, n is equals to length of s. Then we say while n is greater than 2, we'll do something. And finally, we need to check, like, we probably have some sort of data structure to contain the string, probably just like temp of s or something like that. Yeah, maybe we can just do s equals to list of s. Then we can do something like this, get the length. Then finally, we just return s of 0, and is equals to s of 1. Alright, we just use like temp variable, which is like a new list. Say for I in range of length of s, we say 10 minus 1, 10 dot append, so that's a string, so we're going to convert it into an int. We say s of, maybe let's do it like a little bit cleaner. We say current is equals to int of s of I, next is equals to int of s of I plus 1. And we say current.append current plus next. We want to do the modulus operation, mod 10. Then we do n minus equals 1. Then we need to assign s is equals to 10. And actually, we don't even need to do this. We can just doing this is fine. While length of s is greater than or equals to 2. Yeah, then we don't need this anymore. Alright, this looks good. Yep, alright, pass. So let's do a submit. Hopefully everything is good. Yep. So got a submit, and I'm pretty sure if we check the editorial, it will also show that, yeah, simulation, font size very small, directly simulate the operation. Oh, I didn't actually, um, I was wondering why the space complexity is O1. That's because they use they modify the input itself. So that's why they claim that, oh, because that's the case, it doesn't use any extra space. That's always a little bit disingenuous, if you ask me. So yeah, here, what's the space and time complexity? It's actually n squared for the time complexity, and space complexity, at least for me, it's I think it's O(n). Well, in this case, I also modify the input, so it's not really the best practice. But why is the time complexity n squared? Because you can see that um, the first time we're doing the work, we are actually doing like n minus 1 word, and then we're doing n minus 2, n minus 3, n minus 4, all the way until we break at like n minus x, such that it's like less than or equals to 2, right? So if you think about that sequence, with n minus 1 plus n minus 2 plus n minus 3, you actually get the arithmetic series or arithmetic sequence, something like that, which actually just devolves into n square, right? Yeah. So it's a big O of n square. So I'm going to take a look at this problem. Maybe I can think about it a little bit more now. So now the input is so big. Oh my god, only 12% acceptance rate. That's very hard. But you know what? Given that it's such a hard problem, if I have to venture a guess, it will actually be digit DP. Digit dynamic programming. Yeah, there's some crazy topics in the world, man. I'm telling you. I came across this idea, but I never formally studied it or properly studied it. But I heard of it. Let me see. It's probably DP. Nope, I was absolutely wrong. It's combinatorics plus number theory. Just gonna take a gander. If oh, okay, I see. So it's strictly like some heavy math. Oh, so it's just straight up some heavy math code. Yeah, just instead of LeetCode is math code. Interesting. Okay, okay. There's no way in hell I'm solving this problem. If I see this problem tomorrow, I'm not gonna do a video because that is just crazy. But yeah, that's it. That's everything from me. Just gonna show the code one last time. Pretty simple. All right. Happy grinding.